All right, so the next thing we're going to talk about is finding a missing value. All right, these are our examples of that. I'm going to do one, and then I'm going to go back and translate it into steps. Okay? Suppose that these two vary directly. As soon as you see that it varies directly, you can go ahead and assume that the relationship of y over x is always going to be true. Y over x. Now they ask you to find the missing value. All right, so that is the directions. Find the missing value. So if I look at my first set of information, this is my first pair. So negative 54 is going to go over 27 is equal to, now remember, this is y over x, always, y over x. Find x, so I don't know what x is, but I know that y is negative 17. Okay, this is called a proportion. We solved these earlier in Unit 1. The way we solve them is to cross multiply. So I'm going to take negative 17 times 27. I'm going to take negative 54 times x. Give me 1 second. So negative 17 times 27 is negative 459. That's equal to negative 54x. I then divide both sides by negative 54, and I get x is equal to 8.5. And I'm done. Okay, so what did we do when we set this up? First of all, we set up a proportion. Y over x is equal to y over x. Then we cross multiplied. And then we solved for the variable. Okay. Let's do one more of these. So now again, here's the pair that we have. Negative 3 over 9 is the fraction we know. We don't know y now, so I'm going to put the y up top, but x is negative 10. I'm going to cross multiply, divide both sides by 9. Okay, now this is where we're going to use our calculator, so I'm going to show you real quickly. Okay, clear this out. Notice I have 30 over 9, so I'm going to come over here. I'm going to click my fraction button. I'm going to put 30 in the top, and in the bottom I'm going to put 9. Get out from underneath and hit enter, and I get 3 1/3, which is 10/3. Okay, so you can answer any of it that way. You can say y is equal to 10/3 or 3 1/3. I do not want decimals. Right. No decimals. All right, so now let's look at the last topic here. Right. The number of calories varies directly. So as soon as you see varies directly, you know you're going to be talking about this y over x thing with the amount of provolone cheese. Okay, so what I would do now is I would set this up and say, okay, calories over cheese. I would establish that y is calories, cheese is going to be x. If 50 grams of provolone cheese, so cheese goes in the bottom, 50, contains 200 calories. So again, we're doing calories over cheese. How many calories, so we don't know this, so we'll call this up top here y, are in 70 grams of cheese. So this was my first, I'd split on 2 lines, but 50 and 200 went here, calories and cheese. Calories I don't know, I have cheese for the second. I'm now going to cross multiply. So multiply across and here, so here and here. I'm going to get 50y, if I can write that correctly, 50y is equal to 14,000. Divide both sides by 50. And I believe I get 28. Let me see here. 14,000 divided by 50 is 280. All right, and our units are calories. Awesome. All right, so the last thing we're going to do is graphing. I know you've seen this before. We're going to get into more graphing with points and ordered pairs and writing equations, but for now, y is equal to x, all right? Just to liken this, maybe you remember learning about y equals mx plus b, where this was slope, right? Today, we're going to be looking at y equals kx, and we can put a plus 0 on the end. M and k are the same thing. They are slope, all right? So when I look here, I'm going to rewrite this as y is equal to 1 over 1x plus 0. All right, for those of you that don't know, there is a 1 understood to be in front of the x. When I write 1 as a fraction, it's 1 over 1. Okay, and then the plus 0 at the end doesn't change the value of this, but it gives me my y-intercept. So remember, this is my y-intercept, b, which is 0. So we plot the 0 point always, and then this tells me to go up 1 over 1. Up 1 over 1, up 1 over 1, and then I can connect to draw my line. And that is my graph of the direct variation. Okay, so in case you were wondering, k is equal to 1. Slope is equal to 1, m is equal to 1. There's a lot of different questions we can answer from these equations. Last one here, not last, second to last. 5 over 1x plus 0. Okay, these direct variations will always start at 0, 0 as my starting point because we add the plus 0 on the end. This tells me to go up 5, 1, 2, 3, 4, 5 over 1. Remember, y over x, so I'm going 5 in the y direction, 1 in the x direction, 1, 2, 3, 4, 5 over 1. And then I can turn and I can draw my line. Now, let's talk about fractions that are negative. Okay, slope can be negative, it means it goes downhill when we read left to right. The variation can be negative, direct variation. So I'm going to write this in a very special way. I'm going to take this negative, and I'm only going to put it with the 1 up top. It could go just in the bottom, but it has to only go in one place, either the top or the bottom. I'm going to put my x there, I'm going to put my plus 0. Every time I write these, and I'm going to draw a little blue arrow, this, and this. My goal is simply to take the form of what you're given back to slope-intercept form, which all of you have worked with a lot. So I don't want you to learn something else about direct variation. I just want you to say, oh, direct variation is the same equation, and then just know how to do it from there. I'm not trying to create more work. I'm actually trying to what's called scaffold, which is when you build information off of stuff that you already know. So that's why all of these look alike. They all start at 0 for direct variation. I can't stress that enough. According to this, my y says go down 1, go over 2, down 1, over 2. Notice when I graph this, now I also have the negative downhill slope. If you read left to right, slope is negative, k is negative. So that makes a lot of sense. All right, your assignment for tonight models directly off of these very problems.